Throttle warning.
What's up, y'all? You checking out the Frequent Flyer, and I'd like to welcome you guys back to my RC Chop Shop. Now this time we have a build to do here at the Chop Shop, and it's mainly Emax parts. So it's an Emax build. We got a frame here from Crazepony, and this frame, this is a 120 frame, and so we have our frame parts over here. Got a cam mount there, screws, everything we need in here. Let's see, this is what the frame looks like. So small idea what it's going to look like. And the parts we have, we got some Emax 1106 6000 kV motors in here. Let me pull one out so you can see it. So 1106 6000 kV motors here. We're working with a F3 Magnum from Emax. So this has 12 amp ESCs on it. Has a built-in buzzer. F3. We got a JST, but I think we're going to swap that out for an XT30. And that's just about all we need, really. We do, however, have OSD on this board here. So I have a Runcam Micro Swift, and this is version 1. Since we have OSD on the board there, I figured we didn't need any OSD on this here. So I got the version 1 I'm going to put on there. I have a version 2, but I just don't want to waste it because it has OSD. So we're going to use this one with the OSD there. So let's get started. Okay, so I started this build by mounting all the motors to the frame here, using the next to smallest screws. They give you 3 different size screw, actually 4, but one is silver. Make sure you don't use the silver screws because the silver screws are for the props. They're for mounting the props, and they're way too long, and if you go up through the bottom of the can with those screws and they touch the windings inside, then you're going to destroy your motor. So make sure you don't use the silver screws. I have tried the longest black screws that are included, and they don't touch the windings, but I use the size smaller, one size shorter, just to be safe. So they're the next to smallest screws that I used. Next, we're going to mount the stack to the frame here, and you have to pay attention to the flight controller here and find out which way the arrow's pointing. And on this particular one, this is the arrow here. Looks a little strange, but that's the arrow there, so that's letting you know that that's the front. Facing forward is that way. So my USB is going to be off to the left side, and that's okay with me, so I'm just going to mount it this way. This here is the butt of the frame. It looks like a little butt, but anyhow, it's going to go like that. So let's get that mounted. Screws are provided. Okay, so next we're just going to solder all the motor wires to the pads on the ESC. So this should be easy. I'm just going to solder each one on there. I'm not going to really pay attention to which one is on which. And then I can straighten everything out as far as the motor directions and BL Heli Sweet. Okay, so we got the motors soldered up to the ESCs. Not pretty, but it's done. Should work. Now we're just going to solder the power lead onto here. The negative is on the left. The hot wire is on the right. Okay, so we got the power lead on. It's JST at the moment. So we're going to test it to make sure we don't get any magic smoke. Just prepare to yank it out real fast if things don't seem like they're going right. Everything seems to be okay. Yep. Okay, so you guys know I'm a DSMX guy, Spectrum. So I'm going to go with a Spectrum satellite receiver. First of all, there's a row of 3 pads here on the outer edge, and then there's another 3 in the back there. So this front row is for FR Sky and other receivers that take 5 volts, and this back row here is for DSM because it has a 3.3 volt pad right here in the middle. So we have negative up front here, and then in the middle we have 3.3 volts, and over here we have our signal wire, and I believe this is UART2. I'll correct it in the video if I was wrong about that, but we have signal here, 3.3 volts, negative. So I have this official Spectrum wire here for DSM. The black wire is the negative wire, the red is the hot wire, and the gray is always the signal wire. So we're just going to cut this one right here. There, that should be enough room. So what I'm going to do is expose some of the tip of the wire after cutting it. Strip it. I like to use my nails here. I'll just pull a little piece off the edge there. Or if you don't have those, you can use nail clippers. Just be careful not to clip it all the way. There you go, there. There you go. Just enough to get contact. Now I always tin the wires to make them easier to solder on. Just a little tiny bit. Okay, I actually had to go back and resolder that 3.3 volt wire, so it looks clean now. So let's continue on. So what I decided to do now is I decided to use this VTX. This VTX is the one that comes from the King Kong series, and it's the one that's found in the Fly Egg series. So this one is 25 milliwatt to 100 milliwatt switchable, and so I thought that was best. I really like that 100 milliwatt setting there. I like that option a lot, so I'm going to go with this one. And so I also decided to use another top plate for the stack in order to have a place to stick this onto and my receiver. So I'm planning to put one on the top and fasten the other to the bottom. And now all I need is a few standoffs. I don't want it to be too tall, so I'm going to try to locate some shorter standoffs and just have this plate sitting on top there with the flight controller and or VTX on the top and bottom. Before we get to doing that, let's first attach this VTX. And so what we're going to try to do is I have the video in from here, and so I'm going to find the video out on the OSD because I wanted to broadcast the OSD. So I'm going to go to video out with this in here, and my camera I'm going to go to the video in on here. So whatever the camera's seeing, it'll be processed inside the flight controller or OSD, and then it will be sent back to this thing in order for this to broadcast it to my receiver or whatever monitor I'm using. So let's get that done. So we're zoomed in on the flight controller here. You guys should be able to see that here we have the negative. This is the positive 5 volts. This is the video out pad here, and this is the video in. So we want to go to this video out pad. So it's the second one from the left, furthest to the edge, that we're going to put this wire onto. So let's get that. It appears to already have some solder on it. So we want to be having the wire aimed towards the inside. So let's see how steady my hand is here. Look like we got it. It's attached. So now we're going to take these 2 wires here. We're going to go directly to the power lead with these 2. Like we got one lead on. Got the positive on. See if we can get the negative on. I think we're gonna have to use some tweezers just for you guys to be able to see it. Should be it. See, yeah. So that's that. Okay guys, so I got my camera wires tinned up. This just goes into the back of the run cam there. But as you can see, I cut the other edge. So what we're gonna do here, we're just gonna go to this minus here. This is the minus. And then this is the 5 volts. And this is video in. So we're going to put the yellow wire here. The red wire is going to go here. And the black wire is going to go here. Real awkward trying to do this so you guys can see it. Okay, so we got the yellow wire on. There we go. Got the positive wire on. Now we just need the negative and we're done. Looks like it's on now. Let's look at it a little closer. Doesn't look like anything's touching. Nothing's bridged. These are the little standoffs I found. As you can see, I cut them. I didn't want the thread to be up too high. And because I'm going to put some little plastic or nylon nuts on top of these. So let's get those in place. Just going to get them on top here. Yep. I thought about removing these nylon nuts from here and using those for the top, but I have some already for the top and I need that extra clearance. Okay, a couple things that I have to point out now. Number one, this right here, I made a mistake on where to put this yellow wire here that goes into the camera. Turns out that they're swapped around, so the video wire going to the camera is the pad all the way to the left there. So that goes there, and that explains why I wasn't getting any video. But I thought that for some reason this 5 volts wasn't enough to power this camera here. So I went my positive and negative straight over to the battery lead. And I'm just going to leave it like that, but you don't have to do that step. And I'll note in the video that where I was making that mistake, so no one follows behind me and makes that mistake. And so the video wire from the VTX to the board is that second wire there, that second pad there. So make sure you do that, and I'll make sure to point it out in the video. And so now all we have to do is add our side plates on. And let me show you guys how I'm gonna add the side plates on. There's the light, so you guys can see what I did there. So I just put these wires around that little curve there. If you can see that. And I think on the front I might do the exact same thing. So now let's put the steel standoffs or bars on the bottom and then get the camera mount in. Feels like a really sturdy frame. Now it comes with this here. This is the camera mount, and it comes with 2 of these. They're double-sided 3M mounting tape. So the idea is that the camera lens goes through that hole, and the double-sided mounting tape will hold it in place there. And this frame has slots here where you can screw this mount onto this side plate, onto the side plates here, and you can adjust them. You can adjust the angle like that. So pretty nice. The camera should be nice and protected, far from sticking out here. So let's add that. Okay, y'all, so I'm putting my zip ties on. I guess I might as well show you guys how I do that. So here I got some orange zip ties here. I got one on already, but basically I just take it under here, then we're going to close the end. And the purpose of these zip ties is to make the antennas stay up so they don't fall down into the propellers. Try to get them in a good position for optimal reception. Okay, so I tighten them up there. Now the idea is that I'm going to have the antennas from the receiver. I got the receiver sitting right here, by the way. I just put a piece of Velcro, cut some Velcro and put some on the back of the receiver there, put some on that top plate, and I'm just sticking it down like that. And then now that we have these this way, we're going to cut it. Get my toenail clippers out. So we're going to measure this, and we're going to cut it to a little longer than the actual antenna. There. Same thing with this one. Cut it a little longer. And they're flying all over the place. And so now we're just going to put a piece of heat shrink on top of those. Just a tube of heat shrink. You're just going to make sure both of them fit down the tube there. Slide the tube over. And we're going to heat shrink it like that. And there it is. Not pretty, but it works. So if you think about it, the pitch of the quad is going to be about like that. That's hopefully. And the antennas are going to be sticking straight up in the air. And they should be getting good reception all around, no matter which way the quad is facing. So now let's check this out and make sure everything works. Time for beta flight, guys. So I got my dusty computer monitor here. Hopefully you guys can see it clear. Try to show you guys what I'm doing. So let's try this thing. Let's plug it up. And so we're plugged in. Everything seems to be working. As far as the accelerometer is concerned anyhow. Now, what we're going to do, we're going to go to ports. I don't remember which port we got the receiver hooked up to, but we're going to try RX2. So we're going to enable RX2, the serial on UART2. Then we're going to hit save and reboot. So it's back up. Let's check it again. We're going to go here to ports again and make sure it took. So that's switched over there. So now let's go down to configuration. Now we're doing a serial receiver. So we're going to change this from ppm here. Change the input to the second one, serial based. You're going to do that if you're using Spectrum. Well, most people are going to do that if you're using Spectrum, Fly Sky, or the FR Sky, and you're not doing ppm, you're going to have to go there. Now, in this case, I'm doing DSMX, so I'm going to change that from Spectrum 1024 to 2048. More reliable signal with DSMX. Let's go up. We got one shot 125 enabled, but I think this can handle D-Shot 600. So we're going to go to that. I really like multi-shot too, but we're going to do D-Shot 600. And what else? We're going to go down. We're going to disable black box here. We're going to disable the SD card because we don't have that working. We do have an OSD, so we're going to leave the OSD on. Now this part right here is important. The VBAT. Now most people have been having flips of death with the AR Fun Pro 95, the AR Fun, and a lot of these little micros that have 10 amp ESCs and up, and they just do a flip of death and brown out. Now I found out that the source of this problem is this right here. Whenever we load Betaflight on our little quads on the board, this minimum cell voltage is always at 3.3 volts. Now what that means is when the battery voltage sag goes below 3.3 volts, then it's going to reset the flight controller, and we don't want that. So we want to set this to be a little lower. You don't have to mess with the digital idle speed or any of that stuff. Just bring this down to about 2.8, the minimum cell voltage. The maximum cell voltage you can leave at 4.3. The warning cell voltage, you want to put this at maybe 3.2. And because the warning cell voltage is when your battery sags below this value here, then you're gonna hear the buzzer. So you don't want to hear the buzzer all the time. Drop this down a little bit, but don't take it down too far, because then your battery will get really down far before you'll hear any of the buzzer. So I bring it to about 3.2 and leave everything else the same. We're gonna go over here to save and reboot. And all of that should be saved now. I'm going to turn on my receiver back here to make sure I'm getting the receiver signal. This receiver I used before, so it should be already bound to my Devo 10. So let's reconnect. Okay, so let's go over here to the receiver tab. And so we're on the wrong port because none of these sliders are activated. So we're going to try UART 3. Save and reboot. Make sure you save and reboot whatever changes you make to make them take to the board. So let's see. Now we're going to go down to the receiver tab again over here. Check it out. Now all the sliders are moved off to the side here. We see the quad is going crazy. That's because we're on the wrong channel map. So we have to switch this to tare. Spectrum. You're going to go down to spectrum. Okay, so now it stopped going crazy because we switched it to TAER 1, 2, 3, 4. And my 3-minute warning is going off on my transmitter. So now that we have this working correctly, we're going to go down to the modes. So no modes are set here. We're going to set the arm to auxiliary 1. Since my dot is over here, I'm going to slide the highlighted area down to this end. The idea is that when I hit my switch, this dot moves over to this area here. And so I want, when I hit my switch and this dot moves over and it's under the highlighted area, this feature will be activated. So I want to move my slider over here for arm on auxiliary 1. My air mode, I'm going to be using auxiliary 3, and my dot is here currently. All of my switches are away from me on my transmitter, by the way. So this dot is here. So I want to put my highlighted area down the other end. So when I hit my switch, the dot will be under the highlighted area and my air mode feature will be activated. So I want anti-gravity to be activated at the same time as my air mode. So I'm going to put that on auxiliary 3 and slide that one over too, because my dot's still over there on auxiliary 3. My angle mode, I'm going to add that range. And then I want that on auxiliary 3 as well. And so now I want my angle mode highlighted area to be here. That way, when I first switch it on with all the switches away from me, it's on angle mode. So I can take off and stuff like that. And most people like to switch to angle mode when you land. Some people don't have angle mode at all and they just drop their quad and it flips over because they're flying in grass. But I can't do that, obviously, because I'm mostly flying over concrete. So I like to use angle mode for my landings. I don't use horizon mode at all, but you guys can use that. If you're going to use that and set that up on the same auxiliary channels that you're using all of your rates on, you're going to just use the middle right here. You're going to move your slider to the middle in between those two. So if you have a 3-position switch, if you put your 3-position switch to the middle, it should activate that feature if you want that. But I don't use horizon mode, so I'm going to leave that. Now the buzzer, if you have a buzzer, you add that range here. And then I want my buzzer to be set to auxiliary 2. And I want my buzzer to activate when I hit my switch. So I'm going to highlight both of these areas, this whole area here, so that when I hit my switch, this dot will move over there somewhere and my buzzer will be activated. So, and I think that's it. We're not going to update to Betaflight 3.2 yet, because I haven't done that before, and I don't want it to be the first time that I've ever done it to be on camera. So we're going to stick with this, whatever it's on. So make sure you go down here and hit save. That way everything is taken to the board now. As you can see, my angle mode is activated. It's highlighted yellow. And so now we can go down here and configure our OSD if we want. But right now we're not going to mess with the OSD at all. I'm just going to go down here to the motors because I'm concerned to see which way the motors are spinning. So what I'm going to do is I'm going to plug some power up to my motors. Let's plug this 3S battery up on here. So we're going to go right here to I understand to allow my motors to be activated. This, if you hit this switch, it allows your motors to turn on. And so I'm going to go here to the master and go up a little. Now we're going to check to see which ways the motors are spinning. Okay, so I checked my motors, and it seems like, first of all, let me show you guys the motor mapping, how it should go. Looking at the quadcopter from the top here, this edge being the front, this is 1, motor 2, motor 3, and motor 4 up here, and it's displayed up here too. So you want this motor to be spinning this way, in which this one is. You want this one to be spinning this way, which it's not. Mine is spinning the wrong direction on this one. And so this one, you want it to be spinning this way, and it is spinning this way. And this one up here, you want it to be spinning this way, which is clockwise. But it's not, it's spinning counterclockwise. So I'm going to have to go in and change motor 2 and motor 4, the direction. Now, as far as I know, there's no easy way to do that on Betaflight. So we're going to go out of Betaflight. We're going to come right, oops, I didn't mean to do that. But we're going to come out of Betaflight and minimize it. And then we're going to activate Heli Sweet. We're going to go into that. So we're in Heli Sweet. I guess everything is still loading up and everything because I don't see anything there. Okay, there we go. Okay, so I don't want to update or anything now, so I'm going to click no on all of those. Now here, the baud, you want that to be set to 115200, and our port, we want the port to be, you hit this drop down box, and whatever COM shows up in that drop down box, you click on that because that's your quad. and then I'm going to hit connect right here. And so it connected. And now we're going to hit read setup right here. So it says found multiple ESC configuration in Scilab's mode. And it lists all the ESCs here. And it lists all the ESCs here. So we're going to just hit OK. Now the ESCs are being read correctly. Now what we're going to do, you can see down here 1, 2, 3, and 4. Those are the ones that are affected. If you see the numbers there, those are all the ESCs that are affected by the changes that you make. So we're just going to go down and deselect. I like to deselect all of them except for one that I'm working with. So I need to reverse the channel on 2. So I'm going to deselect 1, 3, and 4. So we have 2 highlighted there by itself. Now we're going to turn on break stop, break on stop, hit the arrow there. So now that's on. That means when you hit the disarm button, your ESCs break, which means it stops the props right away, as opposed to letting them spin a little bit, letting them be loose. I like them to stop right away, so I put break stop on. Now we can change the beacon strength and all the beep strength of our ESCs when we first plug it up. The noise that it makes, we can make it louder, and we can set right here the beacon delay, but I don't have to do any of that because we have a buzzer on this model. So we're just going to go to change the motor direction. It's up here on normal. We're going to switch it to reverse, and then we're going to hit right setup right here, and it should write that setup to that one ESC. Right OK. So ESC2 is reversed. Now we're going to go down here and deselect 2, and our other one was 4. So 4 needs to be reversed. We're going to turn break stop on 4, and we're going to change the direction up here to reverse. We're going to hit right setup, wait for the OK. Now the only other ESCs we didn't deal with yet is 3 and 1. So on motor 3, all we have to do is turn on the brake stop, right setup. Oops, I did 3 and 4. Well, you can do multiple ones, but I like to do them one at a time. It's easier to follow that way, I think. And so we're going to do brake stop on for ESC 1, right setup. Now my motors should be spinning in the correct direction now. Now we're just going to disconnect. Now let's close BL Heli Sweet. And let's go back into beta flight. And let's connect. And we're going to test which way the motors are spinning. I'm going to hit this switch again. I understand. And now we're going to raise throttle a little and test the motors. So all of the motors seem to be spinning in the correct direction, and they seem pretty smooth, I might add. So let's see, what do we have to do now? We're just going to go in configuration. I just want to overlook everything in here. Gyro update frequency. This board can handle 8K, 2K for the gyro update frequency and pitted loop frequency. Personalization. I want to change my craft name. So I'm just going to put frequent in there. Spell it wrong and all. So spelling everything wrong. And so let's save and reboot and let's check this thing out. So unplug this. Okay, so it's time to test this thing out, but I guess the only thing I didn't show you guys is what props we're going to put on this thing. I'll show you guys outside.